Well, okay. So you may mistakenly write it down as e raised to minus t over rc. But notice that this decaying exponential starts at capital T. Okay, so I need a decaying exponential that is time shifted by t. Okay, and the way I do that is by using a minus t. So I use minus of t minus capital T over rc. Okay, that is the form. So what I have here, this is simply a decaying exponential that is translated out by a time t. So here, my capacitor will decay with the time constant RC and eventually decay to 0. So this is a pulse response for the situation in which the pulse width t, let me call that the pulse width t, okay, is much, much larger than the time constant. So notice here again, no differential equations. I simply wrote these down by intuition, where by intuition I simply looked at the input initial value, final value, and then did a rising sketch, or looked at initial, final, and then did a falling sketch. Okay, very quickly. So that's the pulse response for t being very, very large. Well, as our next step, not surprisingly, you might imagine, I'm going to do the same thing for a pulse, but in this case with a shorter pulse, okay, where the pulse is not necessarily extremely wide. Okay, so let me go ahead and do that. And in this case, let me pick a pulse that is not really wide, where this is 0 and this is capital T, where t much greater than RC, but rather let me pick a smaller pulse, okay, 0 and t, where this is for the pulse above, and this is for a shorter pulse. And let's take a look at what happens in this situation. Okay, here's my ground node, and this is my node voltage VC. So let me start by drawing a couple of pairs of axes, and just for consistency, let me pick the color red. So here's my input current, and that's my time. This is 0, this is I of t. Let me make it a nice little t here, good. And then let me plot for you the capacitor voltage, and let me mark that as VC of t. This is a good time to switch to green. Okay, so for my pulse here, as before, my pulse is 0 for time t less than 0. And then at time t equal to 0, it switches to capital I. But in this case, it doesn't do it for a long period of time, but then drops down to 0 at capital T, where capital T is not necessarily much, much larger than RC. Okay, so let me say that T much greater than RC is not true. Okay, so T is, in this case, T is maybe on the order of RC or thereabouts. Okay, so let me denote that point down here. So what's going to happen? Okay, what's going to happen in this situation? Okay, so before I go ahead and tell you the answer, let me ask you to go ahead and hit the pause button and think about this and see if you can figure out the answer for yourself, and then you can continue on watching the video.